हेलो फ्रेंड्स, वेलकम टू मैथ्री मंत्रास। हम स्टार्ट करते हैं थर्ड लेक्चर। डिजिटल इलेक्ट्रॉनिक्स के दो लेक्चर ऑलरेडी कंप्लीट कर चुके हैं। थर्ड लेक्चर पे हम चलते हैं। तो देखते हैं क्या है। जो हमने प्रीवियस लेक्चर में टेबल पढ़ी थी उसी को हम आगे कंटिन्यू करने जा रहे हैं, क्योंकि उसमें कुछ डाउट्स रह गए होंगे, तो उन चीजों को मैं अभी और अच्छे से एक्सप्लेन कर देता हूँ जिससे कोई भी प्रॉब्लम्स ना आए। ठीक है, तो आगे देखते हैं क्या होता है। तो फ्रेंड्स, मैंने बताया था वहां पे that in F naught we have already seen that F naught was null operation, and in case of null operation we have seen that whether we are giving input as 0 or 1, it doesn't matter, it will always produce output as 0. That is null operation. Next is F1, that is x dot y. This is the representation of AND gate, and we can also represent like this: x and y. This is also called x intersection y or x and y. This is the second representation of AND gate, and we have already seen the truth table for AND gate. In this case, we multiply the variables, and whatever input we are giving, accordingly we will get output. Next is F2. F2 is x dot y bar. That is called inhibition. I told you that I will tell the meaning of inhibition in next lecture. So this is the meaning of inhibition. That if we are having x dot y bar, so it will be the product of one constant, one variable that is non-complemented and other that is complemented, and these two will be multiplied together, and we will see what we will see here is that if x dot y bar is there, then it means that x but not y, and f3 is x. That it means that I have already told that if we are having x and y variables, and we are also getting at output x and y, same output we are getting, that is called buffer or transfer gate. Transfer gate also it is called. Next is F4. So F4 is x bar dot y. So what is the meaning of x bar dot y? X bar dot y means inhibition again. And how to say? So if we are having x bar dot y, then it means x not x but y. We can say like that, or we can say that y but not x. And this is the second representation: y slash x or y but not x. We can represent like this. F5 equal to y. It means buffer or transfer gate, because x and y I have already told that whatever input we give at input, we will get the same at output. That is called buffer gate. F6 is x XOR y. It means this is the symbol for XOR gate. X XOR y. We will circle the plus sign, then it will become XOR symbol. So in this case, I have already told that it is used for staircase and escalator case. You can see that this will be asked most probably in smaller exams, but it is important. Okay, next point is F7, and this one I have already told that if you are having inputs equal, then it will give output 0, and when we are having inputs unequal, then it will give output as unity. Next is F7. So what is F7 is having? F7 equal to x or y. So what is the meaning of x or y is x or y means and or operation, and here we will add the digits. Means if you are having 0 0, then it will give 0. 0 plus 1 is 1. 1 plus 0 is 1, and 1 plus 1 is 1. Like this you can remember how to learn truth table. So that is very easy. So x union y, we can also call it as union. So x union y is also called OR gate. Now F8 is x or y bar. This is the x or y means OR operation, and this is the complement of OR. So we can say that NOR operation is the complement of OR operation, or NOR gate is the complement gate of OR gate. So this is the representation of x NOR y. Next is F9. So F9 is x or y, x XOR y complement. This is x, this is XOR, this is y complement. So it is x complement x NOR y. This is the XNOR gate. So XNOR is the complement of XOR gate. I have already told you, but how it is, we can see from here. So XNOR is the complement of XOR gate. Next is coincidence and equivalence gate. So what is the meaning of coincidence and equivalence gate is, if you are having equal, we can say like both the inputs are same, then it is getting unity output, and both the inputs are different, then it is having output 0. So that's why it is called equivalence or coincidence gate, because it produces unity output when both the inputs are equal or coincidence. Next is F10, that is equal to Y bar, means NOT gate or complementary gate. In case of NOT gate, whatever we are giving at input, we get complement of that at output. Next is F11. So F11 equal to X or Y bar. X or Y bar. So it is called implication. It can be have two cases, that is X or Y bar or X bar or Y. So how to pronounce that? X or Y bar. So it means if Y then X. The variable that is having bar is containing first, means if Y then X. Next is F12, and if you are having X or Y, X bar or Y, then it will be called if X then Y. Next is F12, F12 equal to X bar. So X bar is called NOT gate or complementary gate. NOT gate or complementary gate. In this case also, if we are giving input as 1, then it will give output as 0, and if we are giving input as 0, then it will give output as unity or 1. Next is F13. So F13 equal to X bar plus Y. This is also case of implication. So how it is pronounced? So it is pronounced as X bar or Y, and what is the meaning of this? If X then Y. F14 equal to X dot Y whole bar. So it is X dot Y whole bar means X dot Y complement. So X dot Y is called AND gate, and complement. So it is complement of AND gate, and we can see this is the NAND gate. So NAND gate is the complement of AND gate. I have already told in the previous lecture. Next is F15. So F15 is unity. Unity means identity. We have seen that unity or identity we have seen in previous lecture. So unity or identity, like we are giving input as 0, then also it is producing output as 1. Like we are giving input as 1, then also it is producing output as unity. So now we can do it again. So in case of unity and null operations, we can see that these two are complements of each other. Null gives output 0 always, and identity gives output as 1 always. Next is F1 equal to X dot Y, that is AND gate, or we can also represent like this, and it is the complement of NAND gate. We can see from here. So F naught is the complement of F15. F1 is the complement of F14, that is AND gate is the complement of NAND gate, or NAND gate is the complement of AND gate. Next is X dot Y bar, that is inhibition, and here we can say that X bar dot Y, these two are also inhibition cases, and these two are complement of each other, because here it is X dot Y bar and it is X bar dot Y. So these two are inhibition operations. And how to pronounce this? If Y is containing bar, then if Y is containing bar, then how to pronounce X but not Y. And if X is containing bar, then how to pronounce Y but not X. Next is buffer gate. Buffer gate two types हो सकते हैं, क्योंकि यहाँ पे दो inputs हैं. So X and Y, these two are two buffer gates. Here it is Y, and we can also see from here that it is X. So these two are buffer gates or transfer gates that gives output as it is. Whatever we are applying input, that will go to the output automatically. Next is F6, that is X XOR Y, XOR gate or XOR logic, that will containing staircase and escalator case. So in case of stairs, we use XOR logic, that is having output as 1 when both the inputs are different, and output as 0 when both the inputs are same. Next is F7 equal to X or Y. X or Y means it is having OR gate, that is the complement of NOR gate. We can see from here NOR gate. F7 and F8 are complements of each other. So NOR gate is the complement of OR gate. So we can remember that the truth table of OR gate, and then we can find easily we can just complement the truth table of OR gate, we will get the truth table of NOR gate. F9 equal to X XOR Y whole bar means it is the complement of XOR gate. And what is that? It is XNOR gate. So XNOR gate is the complement of XOR gate, and It is also called coincidence and equivalence gate. And why it is called coincidence and equivalence gate? Already told that when both the inputs are unity, then both the inputs are unity or both the inputs are zero, means both the inputs are same. Then it is producing output as 1, and when both the inputs are different, then it is producing output as 0. Next is F10 equal to y bar, that is NOT gate. So it is having complementary. So y bar is complementary or NOT gate. Next is F11, that is x or y bar. So it is implication as well as x bar or y. These two are implication examples. X or y bar or x bar or y implications. Next is and how to pronounce this? If y then x, and if x then y. These two are the other representations of the same thing. Next is NAND gate, that I have already told that it is the complement of AND gate, and identity is the complement of zero or null identity, null operation. So thank you friends. अब बताइए, आपको जो चीजें बतानी होती है कि कमेंट्स में बताइए, जो भी प्रॉब्लम्स हो आपको समझ में आ रहा है, अच्छा लग रहा है तो थोड़ा अप्रिशिएशन दीजिए, और बाकी करते रहेंगे हम कंटिन्यू ऐसे ही, जो भी चीजें हैं उनको सुधार करते रहेंगे। ठीक है, फिर मिलते हैं नेक्स्ट लेक्चर में। थैंक यू।